Okay, welcome. We've finally come to the grand finale of our Tromino problem. We're going to try to show that P sub n is true every single time n is congruent to 1 in mod 3. So what numbers would that be? 1 in mod 3? Well, that would be 1 itself, and plus 3 would get 4, or 7, or 10. These happen to be all cases that we've looked at in the previous video. So we've really been working on a big, strong inductive problem where the base cases needed to be solved explicitly, and now we're ready to move along to the inductive step. We've already done 1 and 4 in the very first video when we looked at powers of 2. In the second video, we did the case of 7 by 7 boards and 10 by 10 boards. So now we need to think about how to deal with our inductive step. So the idea is that if we know how to do an n by n board, and of course the n here will be 1 in mod 3, because that's the only type of board that we're dealing with, we can stick on a 7 by 7 deficient board where the first part, the n by n board, steals a corner from the 7 by 7 board. What's so nice about the 7 by 7 board is it gives us rectangles that can be tiled in sections B and C. So that's why in our inductive step we're going to look from Pn to Pn plus 6. And we're going to solve this problem for every n value bigger than or equal to 7. Now you might say, well, wait a second, why didn't we just do this right away? We could have done the inductive step and not worried about the 10 by 10 board and just sort of skip some of these base cases. Well, there is one problem. We do need to make sure by symmetry that the deficiency is always in the n by n section, so that P sub n will allow us to solve this particular section. But if n was ever smaller than 7, we couldn't safely assume that the deficiency is in section A. So we really do need the n value to be bigger than or equal to 7 to make the assumption that the deficiency is in this top left section A. So our job that's left to do to finish off our Tromino problems here is to explain why each one of these sections A, B, C, and D can be tiled. So let's go ahead and do that now. So once again, we're trying to prove that P sub n plus 6 is true. So sitting in front of us, we have our n plus 6 by n plus 6 board. And if we looked at section A, it is an n by n board that is deficient. So P sub n directly tells us that section A can be tiled. Now, moving on to sections B and C, they are rectangles, so maybe by a previous proposition that we talked about rectangles, they can be tiled. Let's check. So what we need to check is that we have a multiple of 2 and a multiple of 3. So our dimensions are 6 by n minus 1. So n, as we know in this particular problem, is congruent to 1 in mod 3. So we'll leave that dimension to talk about mod 3, and the 6 will help us out with the mod 2 part. So 6 is indeed congruent to 0 in mod 2. So there's our multiple of 2. And n minus 1 is congruent to 0 because n is congruent to 1 in mod 3. So we get 1 minus 1, which is congruent to 0 mod 3. So this gives us exactly what we need to tile both sections B and C, because we have the two conditions for our proposition. One of the dimensions is a multiple of 2, and the other dimension is a multiple of 3. Finally, section D. Section D can be tiled since all 7 by 7 deficient boards can be tiled with Trominoes. In this particular case, we really only need the corner, but we've already shown in our previous video that all 7 by 7 sections can be tiled regardless of where the deficiency is. So we'll just use that here again. So this completes our inductive step. Sections A, B, C, and D can all be perfectly tiled with right Trominoes. So in conclusion, we can say, therefore, P sub n plus 6 can be tiled. Okay, so as an extension to this video, you might want to think about how to take a board that's n by n again, but instead this time maybe the n is congruent to 2 in mod 3. It turns out that all of those such deficient boards can be tiled except for the 5 by 5 board. But in a previous video we also looked at the 5 by 5 boards and showed which ones are possible and which ones aren't possible. But every other case, for 2, maybe not 5, but 8, for 11, all of those cases that have n congruent to 2 in mod 3 can be tiled. Give it a try to show why. Thanks so much for listening to this video. We'll see you on the next one.